Capacitors store electrical energy in the form of an electric field. The simplest capacitor is the parallel plate capacitor, which consists of two parallel metal plates separated by an insulating material. The metal plates are called the armament. They function as the electrodes. The insulating material is called a dielectric. Its role is to separate the electrodes and increase the capacitance of the capacitor, that is, the amount of electric charge the capacitor can store. The capacitor is charged using electric power. During this process, negative charges leave one electrode and migrate to the other. Because of the charge difference, an electric field is formed between the two electrodes. The electric field can be characterized by the electric field strength. This is a vector quantity. It refers to both the magnitude and the direction of the force that acts upon one unit of positive charge. In this animation, the black arrows indicate the direction of the field strength. The capacitance of a capacitor, that is, the amount of charge it can store, can be modified in several ways. One way to increase the capacitance is to increase the area of the plates. Another way to increase the amount of the charge stored is to decrease the distance between the plates. The capacitance is also greatly affected by the choice of dielectric placed between the plates. A dielectric can be characterized by its relative permittivity, the ratio of the amount of electric charge stored by a capacitor using that dielectric to that of a similar capacitor that has a vacuum as its dielectric. The permittivity of a vacuum is 1. That of air can be considered the same. The relative permittivity of polyethylene is 2. That is, using polyethylene as a dielectric allows the capacitor to store twice as much charge as it could store if there was air between the plates. If there is paper between the plates instead of air, the capacitance will be more than triple, since the relative permittivity of paper is 3.3.